Hey there, welcome back to Farmcraft. I'm John, this is Large Marge, and this is Large Marge's drinking straw. So this is a big hydraulic hose. You'll see exactly what it's for in a little bit. And this is kind of an interesting video because this hydraulic hose caused me so much trouble, you wouldn't believe it. And what I end up doing to fix this issue is just, well, let's just say it's something that kind of pushed me to the limits of my skills in a lot of different ways. When I saw that this needed replaced, I never had in my mind that it would be so difficult of a repair that it would warrant its own video, but it certainly does. We've got machining, lots of machining. This is a good video, check it out. We're gonna fix up Large Marge's drinking straw. This is the hydraulic supply, from the tank to the low pressure hydraulic pump. There's two pumps on it, one on the back of the engine, one on the front. The main pump line is here, and unfortunately, it has a leak. You can see that oil there dripping. So that line's going to need to be replaced. And, it's just kind of a flex line. It's low pressure because it's on the supply to the pump, so it shouldn't be too awful, I hope. It's probably metric though, so it might be hard to find. All right, so the nice thing is, this is the bottom of the hydraulic tank here, and this handle is a valve. A stiff valve, but that isolates the tank. The tank now is not going to drain anymore, so the only fluid that's going to come out is what's beneath that valve, so this and what's in the hoses, in theory. I don't have a lot of room in this position to get up underneath that. I can't get a bucket under there. So I cleaned out my oil catch pan. It hasn't been that clean since it was new. I'm just gonna dump it in there. It's probably gonna fill that up. I'll have to put the plug back in, dump that in a bucket, do it again. Oh boy. Oh. Glad it's not dumping out crazy, because I ought to be able to get the plug back in when I need to. I wish it would quit splashing so much. Good grief. Rust prevention. Hey, that could have been a lot worse. All right, I'll let that sit there and finish draining. This thing is just steady dripping. I've pushed on the valve and manipulated a little bit. It makes no difference, so hard to tell if it's coming out of the tank or not. It is possible that the valve is leaking that much and it's never going to stop dripping until the tank is empty. It would take a while for 80 gallons to come out at that speed. So now I'm going to work on getting that big hose off, and it's got a bracket right here that's holding it in place, and then some hose clamps. All right, here's the other side of that wall, and in here is where it's leaking. I'm getting worried about being able to replace this pipe because I noticed it looks like it necks down right there. This may be a challenging repair. You surprised? I mean, Large Marge was made in France. That's why everything on the machine is metric. Maybe I should call her Large Marge. This neck down does add a complication, but I don't think it's not the end of the world. Okay, dimensions. It's the ID that matters. 3.48. That's 3.55. 3.53. So I wrote down all those numbers and averaged them, and I get 3.516. You know, I think it's close enough. 3.5 ID would do it. Or I could find the equivalent metric size. 90 millimeter. Alright, let's do the same thing on this side. 2.741. That would be 2 3/4. 70 millimeters. Let me go see what I can figure out. So let me tell you about this hose. This has been one of the biggest challenges I've come across yet. This is a metric hose. It's 90 millimeters here, and it necks down right there to 70 millimeters. And that's not just a splice. They put some tape around it. But if you look at the inside, it's a continuous rubber all the way through. So that was made like that. Obviously, to be able to find this tube with the neck down just like I want it is pretty unlikely unless I can get it from the dealer. Well, I called Case and they said they can't get it. And I told them, well, I can make an adapter between these two sizes. Can you at least find me the hose? And they said they would do a nationwide search, contact all their suppliers and see if they could get it. And they called me back like 10 days later and the answer was no, we can't help you. So I also did some other looking around. I called many hydraulic shops, including, you know, mine that I go to all the time. They're really good. They couldn't get this hose. They told me to try Tipco, which is a kind of like a hydraulic hose chain. They've got many different branches all around, so kind of a network. And they can't get it either. You know, they can get inch sizes in this. So I think you could get 2, 2.5, 3, 4, 5. Well, it turns out that the big one is about 3.5, and this is about 2 3/4. It's too far away to just try to clamp it down and expect it to work, especially this side. I mean, you're 1/2 inch off. It's not going to work. 1/2 inch is 12 millimeters. You're not going to fudge your way through this. We need to get it right. So I really went on a hunt. I started looking all over. I mean, someone's got to have this stuff in metric, right? Well, I couldn't find it. I really couldn't. In all of my calls, people told me to start checking some of the big trucking companies because they use big lines like this. And I called Fleet Pride and I don't know, I called several trucking companies and they couldn't do anything. They can't get it. And searched online, I found one company in the UK where they sell it and they let me even put it in my cart, but they won't ship to the US. And I could not find anywhere online that did. I could check eBay. I don't think I found anything on eBay, but I don't really want to get some piece of junk off of eBay. This needs to work. I mean, if this hose were to like really burst in the middle of using the machine, I'm going to lose 90 gallons of hydraulic fluid really quickly. That's a big hose. Now, I'm sure someone's going to tell me that they could have gotten this at their local Walmart. Heck, it's probably at the 7-Eleven that's down the block. But man, I really tried. I could not find it. After banging my head against the wall for a solid week, probably more, I did come up with a solution. So where the heck did I get these? I'm betting you won't guess. So one of my patrons on Patreon lives in Poland, and he had told me if I ever had trouble to give him a call and he'd see if he could help. For him, this was easy to get. He got online, he ordered it, they shipped it to him. And then he shipped it to me overseas. And, you know, it was a meter minimum, so I had to get this much of it. And this stuff's pretty heavy. I mean, this is, yeah, it's got to be like it's more than 10 pounds. 15 pound, you know, 7 kilo package, something like that. Total cost, including the cost of buying it, shipping it to him, and then shipping it to me overseas, and giving him a little tip for helping me out, was $300, which I'm just tickled to death with. That seems actually quite reasonable. This is really heavy stuff, heavy wall. This is exactly what I need. I just have to make an adapter now to get from this size to this size, but I can manage that. So anyway, yeah, this is from Poland. And my patron's name, he said it was fine to use his name. I'm probably going to butcher the pronunciation, but it's Jakub Urbanski. American pronunciation would be Jacob Urbanski. But Jakob, thank you very much. You saved the day. I really don't know. I did have one last plan that I didn't like at all, and that was going to be to pressure test this and see exactly where it was leaking. And I was going to cut it there and then make an adapter to go between those so that I could at least eliminate that leak. But the problem is it's going to leak again. You know, this hose is probably original. I don't know. But I didn't want to use this old hose. It's leaked once. It's going to leak again. If I go adapting it and then I have to kink it harder, it's probably going to leak very, very soon after. Luckily, I don't have to do any of that. I've actually got the right parts. You know, these are good to up to 150 psi, which is, most of the time, these are going to be under suction, actually. They just need to not collapse, and they certainly won't. So, this is what we're using. Let's get to work and figure out what exactly our adapter is going to look like, because I'm not quite sure yet. So the first thing I want to do, I'm going to cut this down so that I can get kind of a manageable piece under there. It'll be longer than I need if I cut it here, but I want to get close so that I can start to figure out what exactly I'm going to do. So the only thing I have that's going to cut this, because it's going to have steel belting in it, I'm pretty sure, is going to be a grinder. So I'll take that outside. It's going to stink. That smells great. Easier to cut that with an abrasive chop saw, but I don't have one. Man, this is gonna be tough. Okay. This stuff is so inflexible. I pictured being able to bend it around and kind of see what I could do with it, but that's not happening. Any chance I could do a straight adapter somewhere in here? I'm afraid my adapter is going to need to angle, which is going to, that's fine, but that'll make it more complicated. This would be fine right there. So it really seems to me like a 30-degree angle would really help me a lot. If I could have an adapter this size, goes there, and then comes up at 30 degrees to the 70 millimeter. All right, here's my crazy idea. So I need two pieces. I was hoping I could do this in one piece, but I need the angle, so that means two pieces. And I've been doing a little figuring and just kind of figuring out how I want to make it. And this also highlights why at this point we don't change over to metric in the US. All my tools are in inches. So 90 millimeters, I immediately convert it to inches. 70 millimeters to inches, because I don't have metric micrometers. I don't have metric calipers. My lathe is set up for inches. Yeah, I mean, you kind of don't really have a choice. When that's what your tools are, that's what you're working in. I mean, you can try to fight it, but it's impossible to escape, that's for sure. I use the metric system when it suits and when I can, but this is a perfect example. I'm going to be machining these adapters. I'm going straight to inches, so that's how I drew them out. I measured the existing pieces that are on there, like basically one side of the hose is going to the hydraulic tank. Well, that measures, incidentally, exactly 3.5 inches across, and the wall thickness is 150 thousandths. So I just need a tube that's 3.5 inches across and 150 wall thickness, and I'm going to make that one 3.5 inches long. The other one is going to be a little more challenging. It's going to go from the 3.5 inches and it's going to neck down to 2.76 inches. That's what's existing on there. Well, then I'm going to cut them off. I'm going to cut 15 degrees off of this one, 15 degrees off of this one, which when you put them together will total 30 degrees. And then I'll have a 30-degree bend with a neck down. So that's the plan. I'm going to keep the wall thickness 150 thousandths for the most part. When I'm coming down here, I'm not exactly sure how I'm going to do that just yet. There may be some approximating, but I'll make sure I have at least 150 of wall thickness. A friend of mine gave me a bunch of these actually, and these are pins for a very large machine. I think he got them at an auction. I don't know what the steel is, but it is soft. It shouldn't be a problem to machine. Most pins, many pins, are 4140, so I think that's probably what this is, and that'll be just fine. Now, someone's probably going to say, because I'm going to make a lot of chips out of this, that I should go get heavy wall pipe and do it that way, and I could. But finding the pipe, buying the pipe, getting it here, it's just when you have something that you can make work, it's faster and easier and cheaper just to use that. So first thing I need to do is change out this chuck to my 4-jaw. Not because I necessarily need a 4-jaw, I could do it with the 3, but my 4-jaw chuck is bigger. It can handle holding on to this big piece better than this will. Movement of the dial shows how off-center it is, and then I can adjust the jaws to get it running true. It's about 1/2 thousandth. That's running really good. Basically all I need is a tube here that's 3.5 inches. And 150 thousandths wall thickness. So going to be a lot of drilling and boring. It's going to be boring, no doubt about that. 3.53, and I need 3.5, so I need to take 30 thousandths off. So it's not running perfectly true out here, but I'm just not going to worry about that. All this needs to do is be a tube. It doesn't have to be machine tolerance perfect. If I wanted to get it perfect, what I'd have to do is put the dial indicator out here, loosen these, tap it around, tap it down when it's up, and get that right, and then go back here and do that. You have to go back and forth a few times to get it running perfectly true like that. This is definitely close enough. Except I need a new insert. Let's see if that'll cut it. One of the challenges of working with an unknown piece of steel is when things don't go right, you're not sure what the cause is. So I end up struggling with this for a little while. If this thing's going to be like that the whole time, I may have to reevaluate using this piece of steel. I've got a brand new insert. I think that other one might have, even though the edge looked okay, I think it was still worn. And I've slowed the RPM down a little bit. Let's see how this goes. Well, I'm not sure why this is giving me so much trouble. I checked this before, and And yeah, it's not that hard. I mean, I can file it very easily, but it is not machining well. Let me try a different insert. So, I mean, I could use ceramic on it, but that's kind of ridiculous. How am I going to drill it? I guess I ought to see how it drills. That is a brand new edge. I really should have figured this out sooner. Bear with me. I'll get there in a little bit. Same thing. Just eating them up. Alright, this is the best carbide insert I have. And the only slower speed I have is 70 RPM, which I think is going to be too slow. It sort of cut it, but the tool pressure is really high. What is that steel? I don't get it. I need to abort this. It is just not going to turn for me, and I need to be able to bore it out. My biggest drill bit's an inch, so I have a lot of boring to do in there, and it uses the same kind of inserts. Well, you know what they say, curiosity killed the cat, or the lathe, or whatever, maybe the farmer. Let's see if I can drill this thing. Drill it. Alright, this is making me wonder. Do I have an induction hardened outer layer? It's not chromed, but it's drilling pretty easy. This is just a high-speed steel drill bit, so if this drills it, so I don't know why it didn't occur to me that this might have an induction hardened outer layer. I mean, you see that all the time on hydraulic cylinders, but those are chromed. Yeah, see, that outer layer is much harder than where I've been filing it. Down there below the chamfer, it's much softer. Okay, well, this is ceramic. This should be able to cut it. So I'm going to face it off, and usually you're able to see where the hardened layer is and how thick it is. What you're seeing is because it cuts differently. The hard stuff is shiny, the soft stuff is not. However this thing was hardened, it has a variable thickness to it. So turning the OD, I'm going to have to use just ceramic. So I asked the friend that gave these to me. He says they're coupler pins for a train, like a locomotive company. Doesn't know exactly where it was used as far as like coupling cars together or coupling something else. But it does have numbers on it. And I bet you one of you out there probably knows exactly what these things are. Big giant pin, about 3.5 inches across, and hardened on the outside, probably made with 4140, something like that, and used in trains with those numbers. If anybody knows, comment, and I will add it to the description. kind of curious. See about cutting this to a true surface now. Much better. That'll work. That sure looks better too, doesn't it? Alright, let's start boring and see how that goes. So I'm doing 100 thousandths per pass. Oh yeah. Wow. So I'm starting to hit some hard spots. You can see that step in there is because it hit a hard spot and it pushed the tool away from the tool holder. So then it finished it on a different dimension. So I need to anneal that because that's way too thick for what I'm trying to do. See, I didn't go all the way through there. I'm going to use my charcoal forge to get this thing up to temperature. So we're going to anneal this piece of steel. That means change the atomic structure so that it's as soft as it can be. Steel is a mixture of iron and carbon, and it has some interesting properties. When you heat it up to red hot, the atoms are able to reorient themselves, and it just so happens that the orientation that they prefer at that temperature is the hardest state that it could be. So in order to harden metal, you heat it up to red hot and then you quench it rapidly to freeze the atoms in that position. This piece of steel has been hardened on the outside at least, and those atoms are frozen in a hard orientation. So we're going to heat it up to red hot and allow those atoms to orient however they want, but then rather than quenching it, we're going to let it cool off very slowly. That way, as it cools, the atoms are able to continue to reorient themselves, and if you do that, it turns out that it will end up in the softest state possible. And that is what we mean by annealing. Yeah, that's going to do it. So we're just going to let that cool down slowly. Alright, so here we are, annealed in theory. And this is the part that was in the chuck. I never turned that all the way down. So I'm going to grab it on this side. We'll end up polishing this up with some Scotch-Brite. It'll be interesting to see how much it warped too, but we can finish this dimension and we can bore out the ID. I'm going to put some spacers behind it against the chuck so that I have room for my boring bar to come out without hitting the chuck. The thing I really want to know is, am I going to be able to turn this now with regular carbide? Did the annealing work? I don't see why it wouldn't, but it's one of those things. You never know until you try. Yeah, it's warped about 10 thousandths. No surprise, and no big deal. It's got a rubber hose going around it with hose clamps. It'll be fine. Let's see if the annealing actually worked. Well, it worked, obviously. This is just regular old carbide now, and it's cutting just fine. Before it was sparking and ruining my carbide, because I'm an idiot. So 10 thousandths more to go. One side of this fitting is going to be welded, and the other side is actually going to have the hose on it. Obviously, this is going to be the side with the hose on it. Alright, that's looking good. Now I'm going to put a few grooves in this just to help the rubber hose have something to kind of grab onto. Sorry, but it's back to the boring part. 3.2 inches, and we are now at 2.8. So we need 400 thousandths. Yeah, I think trying to do that in one pass is just, I'm chattering. It's sticking out too far. I was hoping to be able to bore all the way through with this one setup, but I'm going to have to do half of it and then flip it around and do the other half. Alright, let's see if that made it any happier. I think you can see there on the reflection of the light. That's what chatter looks like. Lousy cut. That's better. Much better. $30 thousandths shy of 3.1, and we need 3.2, so 130 to go. Alright, now for the last one I'm going to measure the wall thickness, because that's what I really care about. 15 thousandths will put me at 150. That was the easy one. This one's more challenging because it has to have the step down in it. And I want to keep one side the same as this one so that when I cut them, I cut a 15-degree angle on one and then a 15-degree angle on the other, they'll fit. You'll basically have the exact same profile there, and you can weld it together. And then it's going to taper down to our smaller hose. So that's what we're making. I'm going to go ahead and drill and bore it most of the way so that I can anneal it. I'm not going to worry about the OD. This is the one that's going to need the step down taper, so I really can't have anything hard in there. So annealing is definitely necessary. All right, I will let that sit there. I'll probably come back tomorrow and it'll be cold and soft. Yeah, that's definitely soft. All right, that's enough. I am going to go ahead and put a machine surface on it. I'm not going to take it to its final dimension yet, but I do want to have something that will be more regular as far as dial indicator and grabbing in the chuck jaws. It's turning. Alright, a lot of different ways to do this. What I've decided to do, we're going to start out doing the internal portion of the small end. This is going to be for the 70mm hose. I'm going to leave the outside just like it is. So we're going to turn the inside to 2.46 and then we're going to flip. Then we're going to do the other side to completion. That's going to be the side that gets cut at a 15 degree and welded. Then we can flip again, grabbing that side that doesn't have to be that perfect, and do the final OD of this side with the grooves and everything for the hose to grab onto. The hardest part here is doing the taper internally. We're at 2.445. So 15 will put us at 2.46. Uh-oh, 1,000th over. Yeah, that's perfect. Now I need to bore this out. Got my 0, so I need to bore it to 3.2 to this depth set to 0. That's going to be the end of my straight big section. So now you can see I've got a step in there, and I'm going to take that step off at an angle because the inner diameter is the small pipe and that one I just finished is the big pipe. So I just need to make that angle between the two, and that angle is set in the compound. So I'm going to be making cuts just like that. I'm going to be moving the carriage in and out and then cranking the compound to make the cut. And I'm just going to keep cutting on this same angle. Alright, I've been looking at this for a little bit and trying to decide what I want to do, and I don't need the wall thickness to stay continuous on that bevel. It can be a little thicker there, that's just fine. I have a tiny bit of extra length to work with. What I need is 2 1/4 inches, because that's what's on the existing hose adapter for the pump, for that hose to go onto and clamp. So I'm just going to turn 2 1/4 inches down to the correct dimension for the hose, and then I'm going to bevel out from there, and I'm going to end up with some additional thickness on my bevel area, which is fine with me. 2 1/4 inches, it's about 56 millimeters. That's 2.8. So I need 40 thousandths more, but I'm going to let this cool down because it's going to get smaller. So we'll see you back in a few minutes. Alright, it's cooled off. We were at 2.8 before, and now we're 2 thousandths smaller, so it shrunk 2 thou. So I need to go 38, and that's going to land me at 2.76. Obviously the 2 thousandths probably wouldn't matter in this application, but I don't know, when you're machining it's easy to get sucked into the precision of it all. Alright, so here's the hose that it's made for. Oh yeah, it's a good fit. Some hose clamps. That's going to work. So let me go ahead and put some grooves in it. It easily catches my fingernail, so when you compress the rubber over that, part of it's going to squeeze down into there and conform to that, help hold it on. I think that's going to work. So now we need basically to do the same chamfer right there, and this part will be done. So I need to turn the compound the same angle but the other way. Let's see. Alright, I think you can see everything here, and this looks like it's going to work very well. So what I'm going to do here is basically run the compound like this. I'll need to come out more. Take that corner off, and then the deeper I get, the more I will advance in, and I will just keep going until I've reached this corner over here. That will happen when the cutter is somewhere around here. Right there, that angle will connect, and there's plenty of clearance on the chuck. Alright, I've got my two parts. Now I need to make this into one adapter. Now, if the hose had been more flexible, this was my original plan, to just clamp one there, clamp one there. But trying to do it straight, I would really be torquing that hose, and I'm just asking for problems. So putting a bend in this to relieve all the strain is definitely going to be a good thing. I went back under the machine and set an angle gauge to this angle just to make sure I was getting as close as I possibly could. Well, apparently I'm not that good at estimating angles by sight. That's a 50-degree angle. So I need to do 25 degrees on each piece. And that will give me a 50-degree angle. So we're going to cut off that, and we're going to cut off that. And yeah, we're just going to go to 25 degrees here. And now it's just a matter of figuring out how to hold it. So I've got a little V-block. I wish it was a little bigger. You know what? I think I see a better way to set this up. I was forgetting about that clamp. I really want this cut to go well, so let's take a little time and do it. I can even hold the back side with a little piece of scrap here. That's not going anywhere. I'm kind of nervous about cutting it. I've put a lot of work into these getting to this point, and I do not want this to be wrong. But I don't think it's wrong. Alright, now this piece, hold with a V-block behind it. And another scrap. I used a feeler gauge to figure out exactly, but that gives me a nice snug fit underneath, so now I can push down on it. Alright, that's got it really good. This piece is actually up off the bottom a tiny bit, So it really has it right there, and it's perfectly parallel. I like it. So there you go, there's our angle. Just need to weld that together. And incidentally, if you wanted, I could have done a smaller angle and used this offcut to make it more of a smooth elbow. Certainly not necessary in this point. I'm going from a very large flow to a much smaller flow as I go into the pump anyway. It turns the corner with the full diameter of fluid and then goes straight on the smaller diameter. So that'll be fine. If you wanted to make a fitting like this and it was full size the whole way, you would be better off to make it more of a smooth transition, so it's more like a sweep elbow rather than just this hard 50-degree turn. Alright, it looks pretty good and it might work like that, but I'm not in this for the beauty of it. I want this thing to not leak. So I think I'm going to do at least 2 more passes. You know, the hose only needs to come to here and then obviously here. So what I do there doesn't matter. It's ugly, but you know what they say. A grinder in paint makes me the welder I ain't. Alright, it's still ugly, but at least I'm not embarrassed to show you now. It'll pass for a farmer. So there's what's left of that pin. And here's all the shavings, both of those buckets full, and then also the offcuts. I'm sure some people will complain about the waste. The thing is, these were going to go to the scrapyard like that. So now that'll go to the scrapyard, and it's made a very useful part to me. Now what I would like to do is see if I could pressure test it, because I really don't want to put this thing on here, fill it all up with oil, and then find out it has a pinhole leak and have to deal with draining all that oil right back out. I've got it grabbed in the vise. There's a steel plate here and then just a piece of inner tube. So that side should be sealed off. This side, I just turn this down real quick. It goes in there with some additional inner tube, which I need a hole in the center of. There, I should be able to take my blowgun and blow on that. I was worried about that. Yeah, it's not the easiest thing in the world to do, because this has a significant amount of surface area. I don't know how many square inches that is, say 3. So if I pump this thing up to 100 to 50 psi, well, it's pushing out with 150 pounds. The energy builds up pretty quick. You just can't put too much air in it. I'm just going to put soapy water all over it. I don't want to clamp this down and have it get to the point where if something fails, this really is going to propel out of here like a bullet. If it's just my hand, I can only build up so much energy. So, soapy water. This is hazardous. Alright, so I've done this enough that I've convinced myself there's no leaks here. But I think we're good on that, so let's get that painted up. So now that I've gotten to this point, I'm kind of wishing I had made some more grooves here, a little deeper and a little more aggressive for that hose to grab onto, because it's pretty important. If this thing lets go, all the hydraulic fluid in the machine is just gonna dump out and definitely damage the pump. I mean, this failing would be a disaster. Luckily, even though I've already welded everything up, I can still do that. So let's go back over to the lathe. The hose is going to be around this with hose clamps, so this part is not the part that really needs wall thickness, really. You just want to not crush it. I've got 150 thousandths to work with. I think I'm going to plunge in about 50 to make a nice step there. All right, I like that. Alright, I feel a lot better about that. I don't think that's going to be coming off of there. There's the finished adapter. Let's go see if this thing's going to work. Let's see if I can push that through a little bit. To get this on there. Now am I going to be able to assemble it? I need to cut a little bit off of that. So I'm going to go take a little slice off that. I'll be back. I think that's it. Okay, I have 2 clamps on each joint, and I've got a T-bolt clamp on each one of these, and I have another couple of those on order, but I don't have them yet for this one. These are just worm gear clamps, but that's what was on there before, and I think that'll be fine. Long term though, I'd like a T-bolt clamp on there. It's just a little more security, but what I'm seeing looks good, and it looks like we can open the valve and start up this machine finally. It's been a long time. So first thing I'm going to do, we're going to open this valve. And just because I'm a chicken, I think I'm going to let it sit like that for a little. Oh, quit being a wimp. Open it up. Nothing spewing out yet. That's good. Here I'm refilling the hydraulic tank. Much of this is what I drained out of it. Now before we can start this thing, because we've been working on a bunch of hydraulic lines, there's air in the system and there's an air bleeder screw right under this fitting right there. Yeah, there it is. So I need to unscrew that and let it bleed all of the air out of the hydraulic pump. Oh yeah, air's coming out. Can really damage the hydraulic pump if you start this thing up and run it and there's no oil in it. So all this air coming out is oil displacing that air and filling up the pump. Okay. Now we got oil coming out. We got to do the other pump too. All right, now to bleed the oil to this pump, there's supposed to be a bleeder screw right here. And it shows it in the picture. It's very large, big nut. And it's not there. I could take the hose apart here and loosen it, but I actually, it's going uphill to this right here. So that's kind of the high point. So I think I should undo it here and let the air come out till I start getting oil and then tighten the clamps back down. Hopefully I won't regret that. This hose feels like it's in pretty good shape. Pretty stiff though. It might be hard to get it to release. Let's see how this goes. Well, this is pretty funny. Check this out. What's that? That's exactly what I'm looking for. Let me put those hose clamps back. So I just wanted to show you in the manual, it shows that bleeder screw right there, labeled number 2. Air removal plug. And there's the pump. So that's where I was looking for it, because that's where it said to look for it. Didn't occur to me they'd move it to a different place, but of course the place they moved it to is the highest point. Definitely a better place to bleed the air. So let's go bleed it. All right, so here's our bleeder screw. Ugh. Yep. I topped off the tank again. All right, I got the oil right where you want it in the sight glass. We can go ahead and start this thing up and probably top off the oil again after that. So there's the key for the excavator, and that says hydraulic oil tank valve. I was worried I was going to forget about that valve and start it with the pump starved for oil. Apparently I'm known to forget things at times, and that's my solution. All right, we are going to go up in here and crank this thing. All right, after running it, I don't see any evidence of leakage on our suction line. Everything looks good. Adapter looks good. No leaky. Yeah, one thing I noticed is the hydraulic oil level dropped. So they were pumping. That's good. That's just filling up the areas that drained out when I had the hoses off. So I did finally get my T-bolt clamp, and I can really feel it squeezing that hose, and that makes me feel a lot better. There's no way that thing's coming off of there. Same with this one. That's not going anywhere. So there you go, guys. Who would have thought a simple hydraulic hose, one that goes on with hose clamps, would be so darn difficult to fix. But we got it in the end. You know, the only other thing I think I could have done is where it comes out of the tank, I could have welded on an adapter there to bring it to, you know, inch size hoses or something. But then I still have the same problem at the other end on that pump. I either have to make a specialized, very specialized part, flange with the elbow coming down and make that into inch size, or possibly I could take that off and weld onto it directly. I don't know. Either way, that would have been a huge amount of work as well. I'm pretty happy with what we did, and I think that's going to easily outlive the rest of the machine at this point. So I'm glad to have that repair done, but there's more repairs that are already underway, so I can't take it out now and play with it. I am definitely looking forward to that, but it's going to take a little more time. We'll be seeing those repairs in upcoming videos. So thanks for watching. We'll see you on the next one.